Hello friends, in this video let us have a discussion about time delay, low voltage relays. So before getting into the constructional feature and working principle of this type of relays, let us have a clear understanding about how it differs from the other type of timer relays. Usually the timer relays are used to introduce a sequence of operation in the motor control circuits. But these type of relays, time delay relays, are used for other purpose. So let us understand what is their purpose through the coming circuit. Okay, so you see here I have a three-phase motor which is connected with three-phase supply through a three-phase contactor and with the overload relay. So this is a control circuit. So where you have two contactor or two control relays. So one is here, the other one is here. And I have two extra components like I have a RC element to introduce the time delay. Let us understand how the circuit functions. Okay, so when you give the supply from here in the initial state, the current flow takes place through this primary coil, through this overload relay, and it comes back like this. So during this time, the secondary induces the voltage and that passes through this rectifier unit and it passes through this R2 resistor and it goes to control relay and it comes back like this. Also, the current flow passes through this capacitor. So the capacitor is getting charged and a small amount of current is passing through the control relay, which is not enough to trigger at this moment. Okay, so this is the normal operating condition without switching on the control relay. Now I am going to operate the control relay by pressing this start switch. So I'm going to close the start switch like this. So when I close the start switch, the power flow will go through this start switch to the control relay. Now this R2 resistor is bypassed. The current will be flowing through ICR and this ICR will get enough amount of current so that it energized and then so that the contact of this will be closed. So when this contact is getting closed, what happens to this main contactor? The main contactor coil will get energized. So when this main contactor is getting energized, here the contacts of it will be closed. So when these contacts are getting closed, then the three-phase motor is getting energized and the motor start rotates. Right. So now if you release your hand from this start push button at this instant, also the current which is passing through the R2 resistor, though it is a very less amount of current, it is enough to keep the ICR in on condition itself. Okay, so now the ICR is in on condition so that the motor keep running. Okay, at this point of time, let us assume that we have a power cut or a power fluctuation. So let us discuss both points. So first we let us assume that there is a power fluctuation. So the voltage dip. Suppose if you have a 240 volt single phase supply and it reduced to 120 or 150 like that. So the voltage which is reduced may not be enough to trigger this coil, okay, to trigger or to maintain this coil. So because of that the main contactor will go off state, this will go off, but the voltage which is very less to keep the main contactor on. But here what happens, that voltage which is added along with this capacitor voltage keep this ICR in on condition itself. Okay, that simply speaking the capacitor start discharging when the voltage is less. Okay, when the capacitor is discharging, so that current which is getting added up with the secondary current, so these two is added up and the control relay is in on condition itself. So though the main contactor is getting de-energized and the main contacts also get opened, but still the main this control contactor is in closed state itself. So if this happens only for a short time period or I can say the discharge time of this capacitor, before the discharge time of this capacitor, if the voltage comes back to the normal state, what happens, the voltage comes to the main contactor, and the main contactor will again re-energized, and then it will close the contacts, and the three-phase motor will again restart the process without any manual intervention. So this is important, without any manual interventions. In case of a power cut, there is a full voltage is cut. Okay, so in that situation also, what happens? There is no power is transferred from here. So as I told you, the main contact will go off. So this goes off because from here there is no power available to the main contactor. Though this contact is in closed state, also there is no power which is coming from the three-phase supply. But this capacitor will discharge through the R2, and this discharge current is enough to maintain the control relay in the on condition itself for certain amount of time period. So this time period depends upon R2 and C1 value. So time constant RC. So it depends upon the R and C. So if you have the RC time constant more, so it will produce a more time delay. So this means for that time period, okay, for this time period, the contact here of this control relay is going to be in on condition itself. Literally speaking, until the capacitor is discharged to certain value, the control relay is in on condition itself. If the power comes back within this time period, since it is already in closed condition, the main contactor will get energy, and because of that it is going to close the contacts of the motor, and the motor is going to again re connected to the supply, and it is going to run. Okay, and of course when the main contactor is getting the power, it is going to give the power through the secondary, and again the same process, the capacitor is going to charge, and the current which is coming from here is going to drive the control relay also. So this is what going to happen when any small voltage fluctuation, or for a small time if the power is cut. Why I need to achieve this? Because in some applications, without any manual interventions, for small voltage fluctuation for 1 second or 2 seconds, I don't want to turn off the total process. So when after 2 or 3 seconds, if the power comes, automatically it should connect it back. So maybe by this time the motor speed may be reduced from the rated speed to maybe 75% or 50%. And when the power is coming back again, so what will happen? The motor will restart, and again it will reach to the normal speed. So in case if you don't have this setup, what will happen? The motor will be off until the manual intervention takes place, or the operator comes and switch on this process again. So for that only we are using this time delay low voltage release relays. So this is the application of this type of relays. Hope it is clear. If you have any doubts, please let me know in the chat box. Thank you.